All right, so I thought that we would review the number system. This is something you may have seen before, but I thought we would kind of just bring it all together while we're talking about rational and irrational numbers. So, the number system, numbers that you probably learned as a kid, numbers like 1, 2, 3, 4, 5, 100, those are all what we call whole numbers. So, whole numbers. Whole numbers includes 0, but if you don't want to include 0, it's called the natural numbers. So natural numbers would be like 1, 2, 3, 100, just all the positive whole numbers. And so that's the natural numbers. And then once you start including 0, we call those the whole numbers. Note that this could also be something like square root of 16, because that's just 4. So all of those are what we call the whole numbers. And then at one point you eventually learned that there are negative numbers. And so negative numbers, if we include those, something like -1, or -2, or -5, or -57, all still whole numbers but negative, this is what we call the integers. So the integers includes the whole numbers, but it also includes negatives. So that would be the integers. And then this includes really big stuff too, by the way, like -3,148. That's an integer. Beyond the integers, we started having like decimals and fractions and complicated things like that. And so if you start adding things like -7/3 or 0.5 or 0.83 repeating, or what else could we have? 1/2, 14/4, 1.32. All these are decimals that either end or repeat, or they're fractions. These are what we just talked about. These are the rational numbers. They could be represented as a ratio. The rational numbers includes the integers because they could be just all over 1, so those are ratios, which includes the natural numbers and whole numbers. Then you also have irrational numbers. Those are their own separate category. Irrational numbers don't include any of those. Irrational numbers are things like pi, and the square root of 2, and the square root of 3, and e, and like 1.8739, I don't know, just a decimal that goes forever without repeating, without ending. Those are the irrational numbers. And all of this together makes up what we call the real, whoops, I spelled real wrong, the real number system. These are all real numbers. And before you ask, there are numbers that are called imaginary, and they're going to be their own separate box, so prepare yourself for that next year. But when we say all real numbers, you may have heard that phrase before, we're talking about anything in these boxes. It's anything that could be on a number line. Like if I have a number line, and here's 0, and here's 1, and 2, and -1, and so on, any of these numbers, whether they're rational or irrational, goes on that line somewhere. Like pi is 3.14, so somewhere in here. Every number goes on the number line, that makes it a real number. Okay, the only other thing you'll need to be able to do with the rational and irrational stuff is what happens if we combine these? So for each of these, you don't necessarily need to memorize this stuff, you just need to be able to think through it. So for example, if I have a rational number times another rational number, what am I going to get out? Am I going to get out something that's rational or irrational? Go ahead and take a guess, and then let's just try an example and see. A rational number might be something like 5 or 1/2. If I were to multiply those together, it would be 5 times 1, which is 5, over 2, is this still a rational number? Yeah, still a fraction. So rational times irrational is always going to give us a rational number. Let's see if I add them up. If I did like 5 plus 1/2, would that still be a rational number? 5 plus 1/2 would just be 5 1/2, which is still a fraction. It's still a rational number. So anytime you multiply or add rationals, you end up getting a rational number. Just as a side note, this is called closure. So in future math classes, you might hear this, where they say like, the rational numbers are closed. That means that like when you multiply them together, you still just get a rational. Or when you add them together, you still just get a rational. Stays in the family. It's closed. What happens if we mix it up? So like if I do a rational number times an irrational, what would happen? For example, if I did 2/3, which is a rational number, times pi, which is an irrational number, what would I get out? And you can try it in your calculator and see 2/3 pi is just 2/3 pi, and that is irrational. It is possible in one circumstance to get out a rational number. Pause the video and see if you can think of what that might be. How could I do a rational number times an irrational one and get out a rational number? The answer is if the rational number is 0. If I did 0 times pi, I would just get 0, which is actually rational. So there's no hard and fast rule on that one. Typically it's irrational, but sometimes it could be rational. You just have to test some cases and see. Let's try adding them. If I did a rational number plus an irrational one, like pi, what am I going to get? If I take pi and just bump it up by 2/3, it's still going to be irrational. And there's no getting around that one. All right, what if I combine irrational numbers? Like what if I do pi times pi? Or pi times square root of 2. Typically you get out another irrational number, but not always. See if you can think of an example where an irrational times an irrational would give you a rational. Here's an example. Square root of 2, which is an irrational number, times the square root of 2, which is an irrational number. That actually gives you the square root of 4, 2 times 2, which is 2, a rational number. So it's possible on this one to get a rational as well. This one, let's see if we add them up. Typically if you add irrational numbers like pi plus square root of 5, that's going to come out irrational. It's still going to be a decimal that doesn't repeat, goes forever. But it is possible, once again, to get a rational out here. For example, what if I did the square root of 5 plus the negative square root of 5, or just minus 5? Both of these are irrational numbers, but that comes out to be 0, which is rational. So for both of these, it's possible to get either rational or irrational. These are not closed, as we said for the rationals. So again, you don't have to memorize all this. Just be able to figure it out. If you were to be asked, does an irrational number plus an irrational number always give you an irrational number, be able to think through some examples of when it might be the case, when it might not.